So today we'll be solving A-Levels Statistics 1 January 2025 paper. So without further ado, let's dive right in. So the first question is about from chapter 6, which is the discrete random variable. So let's just start with this. So Jen has one fair four-sided red die and one fair four-sided blue die. The red die has sides numbered 1, 2, 3, and 4, and the blue die has sides numbered 1, 3, 5, and 7. The discrete random variable R represents the score from one roll of the red die, and B represents the blue die. Now we just need to write down the name of the distribution of R. So it's basically probability distribution, and the distribution is very discrete and uniform. So it's a discrete uniform distribution. So this is discrete uniform. Now for the next part, we need to find the probability of R is less than 3. So we know that R can be equal to 1, 2, 3, and 4. So less than 3, so they're talking about these two values. So you need to find the probability of landing these two values. So the total outcome is 4. So the total outcome is 4, and the required outcome is these two. So it's 2. So this can be written as 1 over 2. Or you can just keep it like this. It's up to you. Now for the next part, we need to write down the value of expected value of R and the expected value of B. Okay, so for that, it's better if we draw the probability distribution table for both of these. So let's first draw the probability distribution table for the red die. So this represents R, and this represents probability of R equals R. So the first combination is 1, the second one is 2, and the third one is 3, the fourth one is 4. So the probability of landing 1 is 1 over 4, and this is the same, which is 1 over 4 and 1 over 4 and 1 over 4. Now this is a uniform distribution. As you can see from the first part, we have seen this is the uniform distribution, which means all of the values of the probability will be the same. Now let's draw the distribution for B. So let's assume that this is B, and this will be probability of B equals B. So the combinations are 1, 3, 5, and 7. So it's 1, and this is 3, and that's 5 and 7. So this will be 1 over 4 and 1 over 4, 1 over 4 and 1 over 4. Now in order to find out the expected mean of R, so the formula is here equals summation of, let's say we have EX. So the formula is summation of X times probability of X equals X. So if we apply this formula, so this will be 1 square times 1 over 4. Oh, not 1 square, 1 times 1 over 4, and 2 times 1 over 4, and 3 times 1 over 4, and that will be 4 times 1 over 4, which is 1. So this will be equal to 2.5. So that's the expected mean of R. Now let's find out the expected mean of B. So the expected mean of B will be equal to 1 times 1 over 4. That's 1 times 1 over 4, which is gives us 1 over 4, and 3 times 1 over 4, which is 3 over 4, and 5 times 1 over 4, which is 5 over 4, and 7 times 1 over 4, which is 7 over 4. So this should give us a value of 4. Right. Now we need, for the next part, now we need to find out the variance of B. So we know that the variance of B can be written as EB squared, which is EB squared minus EB whole squared. So we already know the value of EB. We just need to find out the value of EB squared. We know that EB squared can be written as summation of B times probability of B, summation of B squared times probability of B equals B. So if we use that formula, so it's basically 1 squared times 1 over 4, 3 squared times 1 over 4. So it's 1 squared times 1 over 4 plus 3 squared times 1 over 4 plus 5 squared times 1 over 4 and 7 squared times 1 over 4. So this will give us a value of 21. Now if we apply the formula that the variance of B is equals to EB squared, which is 21, minus the mean square. The value of mean is 4, so this will be 4 squared, which is minus 16. So this is equals to 5. So now we need to find probability of R plus B is less than or equal to 5. So R plus B less than or equal to 5. So for that, this is basically the sum of the scores on the die. So the sum of the scores on the die must be less than or equal to 5. So let's look at the possible combinations. So the first combination would be, let's say that the possible combinations are R and B. So the first combination is 1 and 1, because 1 plus 1 is 2, which is less than 5. And the second combination is 1 and 3. So 1 plus 3 is 4, so 4 is less than 5. The third combination is, so the third combination is 2 and 1. 2 and 1. The fourth combination is 3 and 1, because this can be written as 3, 1. The next combination will be 4 and 1. So the next combination will be 2 and 3. So as you can see that you can there might be a question that there is also 1 and 4, and let's say it's 1 and 2, because these values can be written as 1 and 4, because the red die can land on 1 and the blue die can land on 4. But as you can see that there is no 4 in the blue die. And the second roll must be the blue die because the first one is red and the second one is blue. So as you can see that these are the only possible combinations for the first one to be red and the second one to be blue. Now we know that the probability of this one is 1 over 4 times 1 over 4. This will be the same, 1 over 4 times 1 over 4, and it's the same for all of these values. So the total probability for r plus b less than or equal 5 will be equal to 1 over 4 times 1 over 4. And since there are 6 values, so you can multiply this whole value by 6. So this should give you an answer of 6 over 16. So that is it for this part. Now we need to find the probability of r square less than b. So r square, if you square this value, it will be 1, and that's 4, and that's 9, and this is 16. So r square to be less than b, let's look at the possible combinations. So if r square is 1, if r square is 1, the value of b must be greater than that. As you can see that there are no values of b which is greater than r square equals 1. And if r square is 4, there is a value of b which is greater than 4, which is 5. So let's first write down the combinations. So let's say that the first one is r squared and the second one is b. So the combinations are 1 and 3 and 1 and 5, 1 and 7, and 4 and 5, and 4 and 7. And each of these probabilities will be 1 over 4 times 1 over 4. So as you can see that there are 5 values of 5 possible combinations. So for probability of r square less than b will be equal to 1 over 4 times 1 over 4. Since there are 5 possible combinations, this will be multiplied by 5. So this will be equal to 5 over 16. So that is it for this part. So the random variable d is defined as the magnitude of the difference between the score on the red die and the score on the blue die. So it's the magnitude of the difference. So if the difference is -4, the magnitude will be 4. Okay. The table below shows the cumulative distribution function of d. So if the difference is 4, the cumulative distribution function is p. Now we just need to find out the value of p. Now let's first find out the probability for the difference to be 4. Let's look at the possible combinations. So the combinations can be So our template would be the first one would be red and the second one to be blue. So the combinations are 1 and 5 and 3 and 7. And let's see if there are other combinations. Okay, so these are the only 2 combinations. So the probability of a single combination will be 1 over 4 times 1 over 4. Since there are 2 values, so the total probability for the difference to be equal to 4 will be 2 times 1 over 4 times 1 over 4. So this is equals to actually 1 over 8. So this is the probability of D equals 4. Now the probability of D equals 4 is 7 over 8. Now the value of F equals 4 will be equal to F3 plus probability of D equals 4, because this is a cumulative distribution function. So the value of F3 is 3 over 4 and the probability of D equals 4 is 1 over 8. So this will be equal to 7 over 8. So that is it for this question. So moving on to the second question. As part of an investigation, Bobby collects a sample of 47 observations and the variable is X. The results are shown in the stem and leaf diagram where A is a constant. And for this, to read this stem and leaf diagram, we need a key. So the key is also given, which is 3 bar 2 means actually 0.32. So let's take a random value. Let's say we take 5 bar 3. So 5 bar 3 will be equal to 0.53. Okay. Now for the first question, we need to find the range of these observations. So we know that this stem and leaf diagram is arranged from ascending order to descending order. So the largest value is 8 bar 7, which is equals to 0.87. minus the smallest value, which is 2 bar 1, which is equals to 0.21. So this is equals to 0.66. So this is the range. The range is basically the largest value minus the smallest value. Okay. Now for the next part, the value of the median of this we need to find the value of the median of these observations. So let's find where the median lies. So there are a total of 47 observations. So Q2 will lie between 47 by 2. So this gives us a decimal value, which is 23.5. So we always remember to round up the value. So it will be 24. Even if it was 23.2, you will round it up to 24. So you always need to round up the values, not round down. So 24th value will be our median. So 24th value, so it will lie somewhere around, so it's 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So this is our median, 4 bar 8, which is 0.48. So 0.48. So that's our median. Now, given that the interquartile range of these observations is 0.31, find the value of A. So we know that the interquartile range, which is the IQR, equals Q3 minus Q1. So let's first find out where Q3 lies. So we know that the upper quartile, which is the Q3, lies between 3 over 4 times 47. So 3 over 4 times 47. So this gives us an answer of 35.25. So the upper quartile will lie between, so it's 3 over 4 times 47, which is 35.25. So if we round this up to 36, so this is the 36th value. So it will lie somewhere on this part. So there's a problem with this. 6 bar A. This is a variable. You cannot write this as 0.6A. We do not know the value of A. So you can just leave it like this. The upper quartile is unknown. Let's call this Q3. Okay, now so the upper quartile is unknown. Let's find the lower quartile, which is Q1. So Q1 will lie somewhere around 1 over 4 times 47. So this is about 47 by 4, which is 11.75. If we round this up, this will be 12th value. So 12th value, it will be 6, 7, 8, 9, 10, 11, 12. So 0.35 is the lower quartile. So we know that the interquartile is 0.31, the upper quartile is unknown, minus the lower quartile, which is 0.35. So the upper quartile is 0.66. So we know the first digit to be 6. Now the second digit will also be 6. Now as you can see that the values of A repeated itself 3 times. So all of these values will be the same. So the second digit is 6. So this will be 6 and 6 and 6. So the value of A is actually 6. So that is it for this part. Now for the next question, we need to calculate the standard deviation. We know the summation of x and the summation of x squared. So we know that the variance is equals to summation of x squared divided by n minus summation of x divided by n whole squared. So this is the variance. Now in order to calculate the standard deviation, you just need to root over this whole thing. So wait, let me just rewrite this. The standard deviation is summation of x divided by n, x squared divided by n minus summation of x divided by n whole squared. So this is the variance. Now if you want to find out the standard deviation, you just need to root over this whole thing. So summation of x squared is 13.4228 divided by the number of observations is 47, as we have seen from the previous question. It's 23.72 over 47 whole squared, and root over this whole thing. So this will be equal to around 0.176. So that is the answer. Now for the next question, Bobby now collects 18 more observations, which is y. So the summation of all of the observations, the 18 observations will be, okay, so we do not know the values. Using all 65 observations, the sample mean is 0.502 and the sample standard deviation is 0.204. Now the first thing we need to show is that the summation of y is equals 8.91. So all of this is 65 observations is the mean of the 65 observations is 0.502. So we can say that the summation of the new observation plus summation of the old observations divided by the total frequency is 0.502, and we know that the summation of x is 23.72. So from this we can find out the summation of y, which is equals to around 8.91. So that is it for the first part. Now for the second part, we need to show that we need to calculate summation of y squared. So for that we need to use the standard deviation. So we know that the variance is equals to summation of all of the data squared. So you can write it like this: summation of the new observation squared plus summation of the old observation squared divided by the total observations, which is 65, minus the mean squared. The mean is, the new mean is 0.502 squared, and the standard deviation is 0.204. So since we're talking about the variance, this will be squared. So from this we can find out the value of summation of y squared, and the summation of x squared is 13.4228. So the summation of y squared is about 5.66. So that is it for this question. Now moving on to the next question. A factory makes rugs and blankets from wool or cotton or polyester, and the informations are given in this part. Now we just need to complete the tree diagram to illustrate all of these informations. So 30% of the items are made of rugs. Made are rugs. So 30%. So the probability is 30%. So if we write it in this decimal format, so it will be 0.3. If this is 0.3, this will be 0.7 because the total probability is 1. So we have used this information. Now for the second part, 60% of the rugs are made from wool. So 60% of the rugs are made from wool. So rugs 60% and wool. So this will be 0.6. So this information is used. And 35% of the blankets are made from wool. So 35% of the blankets are made from wool. So this will be 0.35. And 10% of the rugs are made from cotton. So this will be 0.1. And 20% of the blankets are made from cotton. So this will be 0.2. So we know that this will be 0.45 and this will be 0.3 because the summation of all of these probabilities is equals to 1, and the summation of all of these probabilities will be equal to 1. So that is it for the first part. Now for the second part, we need to find the probability that the item selected is not made from wool. Okay, so let's find the probability that it is not made from wool. Okay, so the combinations are rug, cotton, and rug, or what we can do is that let's find the probability that it is made from wool. So this will be much more efficient. So there's only two combinations, rug and wool, and blanket and wool. So probability of W will be equal to rug and wool, which is 0.3 times 0.6. So that's 0.3 times 0.6 plus 0.7 times 0.35. 0.7 times 0.35. So this is equals to about 0.6. So this is equals to around 0.425. Now why did I find out this value? Because we can say that the probability of not wool will be equal to 1 minus probability of wool. So this should give us an answer of 0.575. So that is it for this part. Now for the next part, given that this item is not made from wool, find the probability that it is a blanket. So the item is not made from wool. Given that it is not made from wool, and we just need to find the probability that it is a blanket. So basically they're talking about finding out the value of probability of B bar W prime. So we know that the formula for this is probability of B intersection W prime divided by probability of W prime. So let's first find out the probability of B intersection W prime. So it's basically B intersection W prime. So it's these two values. So 0.7 times 0.2 plus 0.45. So 0.7 times 0.2 plus 0.45 divided by the probability that it is not made from wool. We know that the probability is 0.575. So 0.575. So this will be equal to around 91 over 115. So that is it for this question. So moving on to the next question, a manufacturer of pet. So basically this is a set Venn diagram. So we need to use these informations to complete this Venn diagram. So let's first use this information, which is 12 cats like all these three flavors. So this will be 12. And let's use this information now. The A intersection B is 19. So the whole value of this is 19. So this will be 7. So this is done. And 20 cats like both A and C. So A intersection C is 20. A intersection C is 20. So this whole value is 20. So this will be 8. Okay. 22 cats like both B and C. So B and oh wait, this will be 8, not that. So 22 cats like both B and C. So this is 22. So this will be 10. So that's done. And 40 cats like wait, 40 cats like A. So the whole value of this is 40. So this will be 13. So that's done. And 45 cats like B. So this is 45 and this will be 16. And 50 cats like C. So the whole value of this is C. So this will be 20. Now, as you can see that the total is 100. So if we subtract all of these values from 100, so this should give us 100 minus 20, 16 minus 22. So there are 14 remaining values which will lie outside the circles. So that is it for this part. Now for these cats, determine whether or not a cat liking flavor A is independent of it liking flavor C. Now if two values are independent, let's say A and C are independent, the probability of A intersection C will be equal to the probability of A times the probability of C. This is like a rule. So let's see if it's equal to these two values. So let's first find out the probability of A intersection C. So the probability of A intersection C will be, so A intersection C is 20 and the total customers is 100. So it's 20 over 100. 20 over 100. And now let's find the probability of A times the probability of C. So the probability of A is 40 over 100. So that's 40 over 100 times, and probability of C is 50 over 100. So it's 50 over 100. So this should give us a value of, wait, so it's 20. So it's 4 over 20, which is 1 over 5. So this is a simplified form. 20 over 100 can also be written as 1 over 5. So this is equals to probability of A intersection C. So we can say that A and C are independent since it follows the rule. So A and C are independent. So that is it for this part. Now, one of these 100 cats is chosen at random. Find the probability that it likes only one of the three flavors. Only one of the three flavors. So let's look at the possible combinations. So it may like only flavor A or flavor B or flavor C. So the total outcome, is 100. And the required outcome is 13 plus 16 plus 20, which is 49. So this is the answer. Now, given that it likes flavor C, find the probability that it also likes flavor B. So basically what they're talking about is this part, which is given that it likes flavor C, now we just need to find the probability that it likes flavor B. So B bar C. So using the formula, this can be written as B intersection C over probability of C. And B intersection C is 22. So that's 22, and the probability of C is 50. So this is the answer. So that is it for this question. Right, now moving on to the next question. A recycling center measures the weight of glass deposited by the public each day. The weight of glass is kilograms deposited at the resource of that. So S is normally distributed across the mean and the standard deviation squared. So first of all, using standardization and showing your working, find the probability that in one randomly selected day during the summer camp, more than 640 kilograms of glass is deposited at the recycling center. So basically, we need to find the probability of S is greater than 640. So first of all, we need to convert this value to Z. So if we convert this value to Z, we can use the formula Z equals S minus mu over the standard deviation. So it will be Z is greater than 640 minus 100 divided by 50. Okay, so this is not 100, this is actually 700. 640 minus 700 divided by 50. So this gives us a value of negative 1.2. So Z is greater than negative 1.2. Now, as you can see that there are no values of Z in the statistical table. There are no negative values of Z in the statistical table. So if we look at the statistical table, there are no negative values of Z. So what we can do is that we can use the formula. There's a formula that if there's a negative value, you can write this as 1 minus probability of Z. Z is greater than A. Now, since the sign is greater than, this must be a negative sign. So there's a whole different formula for this. You can write this as probability of Z is less than A. So we can say that this is equals to probability of Z is less than 1.2. So when the value of Z is 1.2, so 1.2 somewhere around this part, the value of phi Z is 0.8849. So the answer to this is 0.8849. So that is the first part. Now for the second part, we need to find the probability that 700 kilograms of glass correct to the nearest 50 kilograms. So 700 kilograms of glass, which means the upper bound for this will be 725 kilograms and the lower bound will be 675 kilograms, because the degree of accuracy is 50 kilograms. So basically we need to find the probability of 675 is and 725. Now we can write this probability as probability of S is less than 725 minus probability of S is less than 675. Now we have to convert these values to Z. So Z is less than 725 minus the mean divided by the standard deviation. So the standard deviation is 50. So this gives us a value of 0.5 minus the probability of Z is less than 675 minus the mean value divided by the standard deviation. So this will give us a value of negative 0.5. Now we need to convert this negative value to positive. In order to do that, we need to use the formula that probability of Z is less than minus A equals 1 minus probability of Z is less than A. So this is another formula. So probability of Z is less than 0.5 minus 1 plus probability of Z is less than 0.5. Since there is a minus sign, this will be minus and this will be plus. So you can rewrite this as 2 times the probability of Z is less than 0.5 minus 1. Now let's find the value of phi Z when the value of Z is 0.5. So when the value of Z is 0.5, the value of phi Z is 0.6915. So that's 0.6915 minus 1. So this gives us a value of 0.383. So that is the answer for this. Now for the next question, the weight of glass W kilograms deposited at the recycling center in a day during the winter can be modeled by W is normally distributed across the mean and the standard deviation squared. Given that probability of W is greater than 680 is 0.0668 and probability of W is less than 599 is 0.3. Find two equations in terms of mu and standard deviation. So let's first work with this equation. Let's first work with the first equation, which is probability of W is greater than 600 is 0.0668. So probability of W is greater than 680 is equals to 0.0668. 0.0668. So first of all, we need to identify this sign. This is a greater than sign. We need to convert this to a less than. So we can say that this was equals to 1 minus probability of W is less than 680 equals 0.0668. Now if we make this the subject, and then we need to convert this W into Z. So this will be Z is less than 680 minus mean divided by standard deviation equals 1 minus 0.0668, which is equals to 0.9332. So when the value of Z is 680 minus mu over the standard deviation, the probability is 0.9332. So let's first find out the value of Z when the probability is 0.9332. So when the value of phi Z is 0.9332, the value of Z is 1.5. So we can say that 680 minus mean over the standard deviation is 1.5. So our first equation will be mu plus 1.5 standard deviation equals 680. So this is our first equation. Now let's form a second equation. For the second equation, we will use this information that if W is less than 599, the probability is 0.3. So the probability of W to be less than 599, that will be 0.3. So first of all, we need to identify if the sign is less than. So this is a less than sign. Then we need to identify if the probability, if the value of phi z is less than 0.5. So this is less than 0.5. As you can see from the statistical table, there is no value of phi z which is less than 0.5. So what we need to do here is to subtract this value from 1. So we can write this as 1 minus 0.3. And then what we need to do is add a minus sign in the left hand side of the equation, in the probability part. So this will be minus p, and we need to convert this value to z. So this will be z is less than 599 minus mu over the standard deviation. So this is equals to 0.7. So when the probability is 0.7, we need to find the value of z. So when the probability is 0.7, so we do not have a value of phi z to be exactly 0.7, but these two values are close. Now as you can see that the second value is much closer to 0.7 than the first value is much closer to 0.7 than the second value. So let's take this value. When the value of phi z is 0.6985, the value of z is 0.52. So we can say that 599 minus mu over the standard deviation is equals to 0.52. And since there's a negative sign at the front, you can add the negative sign in this part. So we have another equation which looks like this, which is mu minus 0.52 standard deviation equals 599. So this is our second equation. Now in the second part, we need to find the value of mu and standard deviation. So if we solve these two equations, we will get the value of mu and the standard deviation. So solving these two equations, the value of mu is around 620, and the value of standard deviation is about 40. So that is it for this question. Now moving on to the next question. As a part of a selection process, the applicants for a television game show have to take a test and then complete a task as quickly as possible. The test score is W, and the time taken to complete the task is T minutes, are recorded for each applicant. So the summary statistics and the summation of all the values are given. First of all, we need to find out the value of R, which is the product moment correlation coefficient, which is basically the PMCC, or sometimes it can be called R. So let's find this out. So we know that R is equals to summary statistic of W and T divided by root over summary statistic of W times W multiplied by summary statistic of double T. So we know the summary statistic of W and T and W and W. So now we just need to find the summary statistic of double T. So let's calculate this. So we can say that the summary statistic of double T can be written as summation of t squared minus summation of t whole squared divided by n. So summation of t squared is 14837 minus summation of t is 635 divided by the value of n is 30. So it's 30. So this will be equal to around 1396.17. Now we can just substitute the values. So summary statistic of SWT will be minus 1648.83. 648.83 divided by over. So summary statistic of W is 2396.97. That's 2396.97 times this value is 1396.17. So this gives us a value of negative 0.901. So that is it for the first part. Now for the second question, a scatter diagram of t against w is plotted for these data. State two features of the graph that you would expect to see given the correlation coefficient in part A. Now as you can see that the value of R or the value of PMCC, so this is close to -1. So which means that this is, first of all, this is a negative value. So which means this will be a negative correlation. And the second thing is that this is close to -1. So which means that this is a strong negative correlation, strong negative linear correlation. So if you want to explain this, so we need to state the two features of the graph that you would expect to see. So the first feature is that, a linear relationship between t and w, and the second feature is that the gradient will be negative. So it will be a negative gradient. So that is it for this part. Moving on to the next question, we need to calculate the equation of the regression line of t on w. So first of all, we need to calculate the value of b. So we can say that the value of b is equals to the summary statistic of w and t divided by the summary statistic of w and w. So this is basically a formula. So if we apply this formula, b equals summary statistic of w and t divided by the summary statistic of w and w. So this is negative 1648.83 divided by 2396.97. So this is equals to somewhere around negative 0.69. Now we need to calculate the value of A. So in order to calculate the value of A, we can say that the value of A is equals to summation of t over n. So this is another formula. So A is equals to summation of t over n. So the summation of t is 635 and the value of n is 30. So this is equals to around 40.4. So the equation of the regression line will look something like this. T equals 40.4 minus 0.69 W. So that is it for this part. Now for the next question, we need to give an interpretation of the gradient of this regression line. So the gradient is around 0.69. So the gradient is about 0.69. So the gradient actually represents the change in y-axis over the change in x-axis. So which means that the x-axis is w and the y-axis is t. So which means that if x increases, if w increases by 1, time will decrease by 0.688. It will decrease because the value of gradient is negative. So it's negative 0.69. So the interpretation will be, if w increases by 1, t will decrease by 0.69. So that is the interpretation of the gradient. Now for the next part, state for each of the following whether the value would increase or decrease or stay the same as a result of applying this change. So the change is that the manager then recalculates the PMCC. Okay, so this is not the change. The change is that the manager now decides to double all the values of W to make them into percentages. So if we double all the values of W, what will happen to the PMCC? Okay. So if we double all the values of W, since the W is in a ratio format, we can say that the PMCC will stay the same. So the product moment correlation coefficient will stay the same. Now for the second part, the magnitude of the gradient of the regression line. So if x increases by 2, if W increases by 2, which means that the value of W is doubled. So the line, if the line looked like this, or like this, the new line will look something like this. It will be a shallower line. So we can say that the gradient will decrease. Now the t-intercept of the regression line, the t-intercept, which means the y-intercept, they're basically talking about the value of a. So a will not increase nor decrease because a is equals to the summation of t over n, and the value of t did not increase nor decrease. So the y-intercept, basically the t-intercept, will remain the same. So that is it for this part. Now moving on to the last question, is that we have a box plot and we have a random sample of 200 of cabbages, and the weight of each cabbage is recorded. So first of all, we need to use the linear interpolation to estimate the probability that a randomly chosen cabbage from this sample has a weight of less than 570 grams. So 570 grams lies somewhere around this part. Now as you can see that the median is at the very center of the box plot, and the median is n over 2, which is 200 over 2. So the median, so at this point there are 100 cabbages, and at this point this is the upper quartile. The upper quartile is 3 over 4 times n. So this gives us a value of 150. So this is 150 cabbages, and there are a total of 50 cabbages between these two lines. So at 570, the value of cabbages will be, wait, so at 570 the value of cabbages will be 110. 220 minus 110 divided by 200. So the probability is 110 over 200, which is 0.55. So this is the answer, but we cannot use this method. We need to use the linear interpolation to find out the number of cabbages at this point, and then we can calculate the probability. So if we use linear interpolation, let's say that at this point the number of cabbages is unknown. Let's call it x. So there are x cabbages at this point. So the basis of linear interpolation is we're equating the ratio of the lengths. So this length is x minus 100. So this is basically x minus 100. So x minus 100 divided by the whole length, which is 150 minus 100. We're talking about this length. So it's 150 minus 100 equals to this length divided by this length, which is 570 minus 550 divided by 650 minus 550. So it's 570 minus 550 divided by 650 minus 550. So from this we will get the value of x. So from this we will get the value of x to be 110. So the probability of x to be 110 will be 110, which is the required outcome divided by the total outcomes, which is around 0.55. So that is the answer for part A. Alright, now we need to find the minimum weight of a cabbage that the supermarket manager would classify as extra large. So extra large cabbage is known as Q3 plus 1.5 times Q3 minus Q1. So we know the value of Q3 to be 150. So this is Q3. Let's find the value of Q1, which is the lower quartile, which is this part. So the Q1 is basically 1 over 4 times 200. So this is 50. So the minimum weight will be, so let's first find out the value of Q3 plus 1.5 times Q3 minus Q1. So Q3 plus 1.5 times Q3 minus Q1. So the value of Q3 is 150 and 1.5 is a constant. So it's 150 minus 50. So the minimum weight, okay, so we're talking about the minimum weight, but we're using the value of frequency in this part, which is the number of cabbages, so we cannot use these values. So when at the upper quartile the value of weight is 650, so we need to use this value, and the lower quartile the value of weight is 450. So Q3 is 650 plus 1.5 times 650 minus 450. So this is equals to around 950 grams. So this is the minimum weight. Okay. Now moving on to the next question. The supermarket manager assumes that the weights of cabbages supplied to the supermarket may be modeled by a normal distribution. Explain whether or not the box plot supports this assumption. So for the basis of normal distribution is that the curve needs to be symmetrical. Now as you can see that this box plot is perfectly symmetrical. This length is equals to this length, and the median is at the very midpoint of the box. So we can say that normal distribution is supported as the box plot is symmetrical. So normal distribution is supported. So that is the answer for this part. Now moving on to the next question. The farmer records the weight of every cabbage harvested from a field and classifies any cabbage whose weight is more than 2 standard deviations above the mean as an outlier. Assuming that the weights of the 2 cabbages from this field may be modeled by a normal distribution. So the weight is normally distributed across the mean and the variance. Find the probability that a randomly selected cabbage harvested from the field would be classified as an outlier using the farmer's method. So we know that first of all, we need to find out the mean value. We know that this is a perfectly symmetrical normal distribution. So if this is perfectly symmetrical, the value of mean will be 0. So this is actually a well-known fact. If the normal distribution is perfectly symmetrical, the value of mean will be 0 and the value of standard deviation will be equal to 1. So you can say that the Z, which is the weight, is normally distributed across the mean, which is 0, and the standard deviation squared. So a weight which is more than 2 standard deviations above the mean is an outlier. So the value of Z is 2. So we need to find the probability that a randomly selected cabbage harvested from the field would be classified as an outlier using the farmer's method. So basically we need to find the probability of Z is less than 2. Now if we look at the statistical table was the previous question. When the value of Z is 2, the probability is 0.9772. Okay, so outlier means a maximum value. So it cannot be less than 2. It must be greater than 2. Z is greater than 2. So we know that this can be written as 1 minus probability of Z is less than 2. And 1 minus probability of Z is less than 2 is 0.9772. So the answer will be 0.0228. Now the mean weight of the cabbages harvested from this field is 560 grams. Given that a cabbage with a weight of 1000 grams is classified as an outlier by the farmer, find the maximum possible value of the standard deviation of the weights of cabbages harvested from the field. So we know Z is normally distributed across the mean is 0 and the variance is 1. But now we don't know the value of mean. Okay, so we know the value of mean to be 560. So we can say W is normally distributed across 560 and the standard deviation squared. So we need to find the maximum possible value of standard deviation. So basically the probability of W to be greater than 1000 is, so if W is greater than 1000, this is an outlier, and we know that the probability of an outlier, which is the maximum outlier, is 0.0228. But this is for the value of Z. But the value of W will be the same since we're talking about the probability. So it's 0.0228. Now we need to convert this value to Z. So z is greater than 1000 minus, okay, so this will be a less than sign because the minimum weight has to be 1000 grams because the cabbage, because they have said that given that a cabbage with a weight of 1000 grams is classified as an outlier. So this can be less than or equal to, or but for normal distribution we usually use the less than sign. So this will be less than, the probability of z is less than 1000 minus the mean value, which is 560, divided by the standard deviation, equals 0.0228. So when the probability of z is 0.0228, the value of z will be 2, as we have found from the previous question. So we can say that 1000 minus 560 over the standard deviation is 2. So from this we can find out the value of the standard deviation, the maximum value for the standard deviation. So the maximum value for standard deviation will be 220. So that's it for this question, and I'll see you guys in the next class.